right, so this will be our last Zoom session. Obviously, no, you don't have one tomorrow. So today you should have gotten that. Hopefully you're able to do it with no problem. I don't think it was that hard if you've looked at it yet. I said it's due tomorrow, but you should be able to do that today. Pretty simple. It shouldn't take very long. You don't have to do it till tomorrow. I won't be even looking at it to put the grades in until tomorrow. Okay. And then make sure you send me your 10.4, a picture of it today sometime. A lot of people's already. So thank you for that. So, but if you have questions, we'll go over those now. Do we have any questions from the homework?
Could you do number 15?
15 from the homework? Or 15 from the notes?
Homework.
Homework? Okay. What other questions you got?
17.
Okay, the star one.
20 through 25. I was just confused because I got yes for all of them, so I knew that was
We'll talk
wrong.
about those, yeah. So like when you get the notes packet, the blank notes online, there's like always a ton of exercises at the end. You don't have to do all of those. I would just pick and choose a few. There's in some cases there's lots of them, in some cases there's not, but they're just some more example problems for you to work through. And I key to the 10.4 notes, those are already online, so you can go back and look at those. Okay, let me share my screen. And just shout out if you have questions, because I can't see my chat, or if you have your hand up when I share my screen. All right, can you guys see it?
Yeah.
Thumbs up? Okay. So there's 3 through 8. You guys didn't have any questions on 3 through 8?
I have a question on 8.
So it's asking you for the measure of arc WX. So you have to find the measure of the other 2 arcs that make up the circle. So they gave you this one. Excuse me. Then this inscribed angle, if you double it, you get the measure of the arc. So that's 150. And
Wait,
then
so what's the like formula or whatever to find each side?
well,
Like
the full
y-axis
circle
and
is
WX.
the full circle is 360. So to find an arc, if you have the inscribed angle, so you see how this angle creates have the angle measure of the inscribed angle, you just double it. So times it by 2, and that'll give you the measure of the arc.
Okay.
And then in reverse, if you're given the arc, you divide it by 2, or multiply it by 1/2 to get the 60. So either way, depending on what you're given.
Okay.
And then 150 and 110 is 260, and then subtract that from 360, and you're left with 100.
What about number 7?
So with number 7, it was about VU, this arc here. So you know that this is a semicircle here. So the whole half the circle is 180. You know this angle here is 30, double it, you get 60. So the other part of the semicircle has to be 120.
Okay.
Okay. All right.
Do you think we could do 17 for the homework? Or after, I think someone had a question on 15, but like whenever.
Yeah, we'll go 15, 17, and then 20 through 25.
Okay.
Could you like show the answers for 10, 11, and 12?
Yeah, there you go.
Okay.
So these are where you have 2 congruent angles. So angle A and angle B are congruent because they create the same arc CD. So therefore they'd have to be congruent. And then angle C and angle D are congruent because they both create this arc over here. And the other 2 problems are pretty similar. Okay. All right. So let's look at 15. So there was kind of 2 ways you could go about doing 15. One thing, if you notice, you see that there is a quadrilateral inscribed. And if a quadrilateral is inscribed in a circle, opposite angles are supplementary. But what I did is I said, okay, well, I'm going to look at this whole circle, and then it's only missing, the only arc that's not labeled is JK. So I added up these numbers here, 54, 130, and 110, subtracted from 360, and I got 66, which was left. So then to solve for A, this angle here, angle L, actually creates arc MK. So I added 54 and 66, and I got 120. Then I know that 3A, this angle here, is half of 120. So then I just solve the equation. Half of 120 is 60. 3A equals 60, so A is equal to 20. So I just used the theorem that the inscribed angle is half the arc that it creates. That's what I did. I thought it was easier. And then to solve for B, so angle M here creates arc JL. So I added 66 and 110 and got 176. And then I set up the equation, this angle 4B is equal to half of 176. And then I just solved the equation and got B is equal to 22.
For number 13, how'd you get 185?
So just like I mentioned, if you have a quadrilateral whose vertices are on the circle, that's called an inscribed quadrilateral. Opposite angles, so angle Q and angle S are supplementary, and angle R and angle T are supplementary.
Okay.
So I just said, okay, well, if this is 80, angle T is 80, angle R has to be 100 because they have to equal 180, the opposite angles. And that's the main stipulation for a quadrilateral to be inscribed. Opposite angles have to be supplementary. If
Is that
they're
the same
not,
thing
you
for
can't
number
actually
14?
draw it on the, you can't inscribe it where the vertices are on the circle.
Does that rule apply to number 14 too?
Yes. Mhm.
Okay.
And this is actually an isosceles trapezoid. But yeah, M is equal to 120 because 120 and 60 is 180. And then 2K is equal to 120, so K is 60. All right, so let's look at 17 through 17. So the main thing to understand is what they tell you up here is all of the inscribed angles in this star are congruent to each other. So that means that all the, basically the points of the star where you see angles, all of those angles are. So what that means is that all 5 of these arcs that make up this circle are going to be congruent as well. So I just said, okay, there's 360 degrees in a circle divided by 5 congruent arcs, and that gives me that each arc is 72. So once I got there, the 2 questions, find the measure of the inscribed angle for each star. So what I did is I said, well, the arc is 72, so the angle is half of that. So each angle here would be 36. And then if I want to find the sum of all 5 of those angles, I just multiply 36 times 5 and got 180. Does that make sense?
Wait, so why wouldn't you divide 72 by 2?
Well, multiplying by half and dividing by 2 is the same thing. Any other questions about number 17? Okay. All right, so let's go over 20 through 25. So one thing you have to just, the only thing you really have to keep in mind when answering these questions is that in order for these quadrilaterals to be inscribed, opposite angles have to be supplementary. It means they have to equal 180 or add to 180. So that's why 20 and 21, a square and a rectangle, those would be a yes. Because if you think about it, a square and a rectangle, all of the angles are 90 degrees. So opposite angles would be supplementary. That'll be the reason for that. Now I said a no for parallelogram, kite, and a rhombus. So think back to the properties of angles in those figures are not necessarily, angles in a parallelogram and rhombus are congruent, but not necessarily supplementary. So that's why it's a no for them. And then isosceles trapezoid. One of the properties of an isosceles trapezoid is that opposite angles are supplementary. So those three, whoopsie, square, rectangle, and isosceles trapezoid are the only quadrilaterals that their opposite are always supplementary. So we can definitely inscribe those in a quadrilateral.
But for the isosceles trapezoid, how do you know that all of the opposite angles are supplementary?
That's one of the properties of an isosceles trapezoid.
Because I thought like if you draw it out, then it would be.
So if you remember the isosceles, like you have your legs are congruent, so your base angles here are congruent, and then your top angles are congruent. So, and then opposite angles are always supplementary. Trapezoid.
Oh, okay.
Yeah.
Thank you.
You're welcome. And that was it for the homework for there. Stop sharing. All right, anybody else have anything to talk about? Go over from 10.4? You feel good? Thumbs up, club? So yeah, so make sure you do the Google form, get that into me. If you have any questions, I'm gonna adventure out. I'm really excited about it. I'm gonna go to Target, but I will be back. So if you have questions, I will be here. And then make sure you send me your 10.4 homework. Okay, and then you're done. You don't have any homework over spring break. That's good. And then we come back, we'll kind of continue with circles and start chapter 11. 10 and 11 go with each other. We'll have a on 10 and 11 on the road. Okay. So they sent us an email about like stuff that we can send you guys to like, nobody's going anywhere for spring break, yeah? No one's going anywhere? Have a special like retreat that they're going on. And so they sent us an email about stuff, video, like to do videos or whatever and put them out there for you guys. I couldn't think of anything. Nothing. And so one thing that they're asking is that if you want to, and they'll probably talk about this in an email, like if you want to like film yourself, record, like a lower school kid.
Wait, sorry, it's glitching on my end. What are you saying?
Do is like put stuff out there for like stuff that we can record videos and all that kind of stuff for you guys to kind of like keep you entertained over spring break. But they were also saying that if you wanted to, you could video reading a book to like a lower school kid or something like that you can do to kind of help the lower school or primary school. So just putting that out there. You might get an email about me doing that. So it might be fun. I don't know. The only thing that I could think about doing is how to run 6 miles. Put your shoes on. Let's go. That's it. That'd be pretty boring. So
Yes, I did 4 yesterday. Or no, I think I did 5 yesterday, so I'm almost at 6.
you got it. I've been doing like so bored 8 in the morning and then 4 in the afternoon. I know. So bad.
I can't even run across my driveway. Like, how do you
Come
do
on,
that?
Allie. All right, I challenge all of you. Put your shoes on. Running.
No, I know. I go
Bands
running
on,
every.
go for a jog.
I just can't do long distance. That's all.
You can. You can. You're.
I mean, my abs.
Oh, and I got asked to be the assistant coach of the cross country team for middle school.
Woo.
Yeah, I'm excited. So, anyway, you guys have fun. Spring break. Do something fun. Get outside. Okay, and don't forget to send me that stuff. Okay. And if
Miss
you need help
Richard,
with anything, just email me. Yes.
I
Hayden.
have a quick question before.
Yeah, if you're done, guys, you can go. Miss you.
Thank you.
So
What is that sound?
All right, Hayden, number 4 on the homework.
no, I just have like a question in general.
Okay, what's your question?
But I guess I could use number 4 as an example. So if I like draw it out and like the shape in it. So the angle of the like 2 lines, what is that called?
The angle
I wrote
of,
it down, but
oh,
I
that's
can't
called an
find it.
inscribed. I'll share my screen with you here. Hold on. Angle here, you're talking about like number 4, angle G, that's called an inscribed angle.
Okay. And that is half of the,
That's
Uh,
half the arc.
okay. I lost the sheet page of my notes that I wrote this on.
Okay, well, I posted the key to the notes under chapter 10 and topics.
Okay. And the other two angles are,
Which
they just
angle?
add up to 360
Oh,
with
you mean
the
the
other
arcs?
thing.
Yeah, the arcs, yeah.
Okay.
So the entire 360. So you have to just, whatever arcs you're given, you can subtract and then find the other arcs. Depends on like the information that you're given.
Okay. All right, got it. Thank
Okay.
you.
All right, guys.
Bye.
Bye. Have a good. Ellie, you doing okay?
Yes, I just had a quick question about 7 on the Google form.
Okay, let me pull it up. Number 7.
Yeah.
Let me pull it up. Oops. Hold on. Hold on. Okay. Let me pull up my Chrome. Okay. Let me go to my drive. Oh, my internet's a little. Okay. All right, number 7.
The point of tangency.
Yeah, so that's the point at which the tangent line touches the circle. Let me share my screen here. So like, if you look here, point E, that doesn't even touch at all. So like, I'll give you an example. This line right here, H, is actually tangent, and the point of tangency would be point B, because that's actually where it touches. But B is not an option. You have E, C, D, and A. So E wouldn't be it. C is the center. And D is actually, it's a point on the circle, but there's no line through it. So it'd have to be A.
Okay. Gotcha.
All right. All right.
Bye.
Bye. I'll talk to you later. Bye.
Bye.